There are many estimates and simulations of the direct and indirect effects of climate change by country and region. A consensus view is that while terms of trade spillovers may be significant, they are likely to be very small in relation to the direct effects. This set of predicted effects of climate change relative to baseline GDP is representative of the much broader literature. In this simulation result, Southeast Asia is the largest beneficiary from trade spillovers. However, along with South Asia, it is also by far the biggest loser from direct climate change effects. These predictions indicate that even if spillover effects are positive, they are unlikely to be sufficient to offset direct climate change losses. The direct effects of trade on climate change themselves are small. Emissions from international transport total about 3% of total global emissions. So our interest is chiefly in whether climate change will increase or diminish the possibilities of gains from trade and in the role of spillovers from trade. A recent study of a large panel of manufacturing firms in Côte d'Ivoire compares changes in labor and capital productivity relative to normal temperatures. It found that a 1 standard deviation increase in the number of days with mean temperature above 27 degrees Celsius, that is, about 51 more days per year, was associated with substantial declines in output per worker and output per unit of capital invested. Firms could mitigate these effects by spending more, for example, on air conditioning equipment, but the overall effect was to hasten the rate of firm exit from the industry. In other words, the international competitiveness of Côte d'Ivoire's industry is reduced by climate change effects. This reduces the potential for income growth and job diversification, which in turn raises the costs of achieving critical SDG targets, not only environmental but also economic and social. Climate change greatly impedes efforts to protect the natural environment. As an example, the impact of sea level changes and ocean acidification is expected to inflict severe damage on tropical marine ecosystems. According to the World Bank, a 2 degrees Celsius increase in the global temperature will cause widespread food shortages, unprecedented heat waves, and more intense cyclones. If the temperature rises by 4 degrees Celsius, then sea levels in Southeast Asia will rise by 110 to 115 centimeters. Ocean acidification and warming of 4 degrees Celsius are also enough to kill all coral, which is the key tropical marine ecosystem. This, in turn, will reduce the productivity of an important asset exploited by poor households for their livelihood. Similar threats apply to Asia's large low-lying river deltas and coastal areas, which are home to very large populations. These deltaic areas are also the most productive and most intensively farmed of Asia's agricultural regions. As production patterns change, so too will the patterns of trade and the value and distribution of benefits from trade. Climate change also undermines potential gains from trade in manufactured goods. Most of Asia's manufacturing takes place in cities, and most cities are located on the coast or in low-lying river delta areas. These are imminently threatened by rising sea levels. Flooding and other climate change-related damages will raise the cost of production and trade, reducing their potential to contribute to SDGs of increased income through more productive employment. This diagram illustrates predicted changes in the high-tide flooded area of the Bangkok metropolitan area. This region accounts for almost 40% of Thailand's manufacturing output and is very vulnerable to rising sea levels. In 2011, widespread flooding in Thailand wiped out industrial estates in the Central Plain and interrupted global supplies of many products such as hard disk drives. So far, we have seen that the direct impacts of climate change are expected to have disproportionate effects on countries in the tropics and will mainly tend to reduce production capacity and productivity. This will directly impair progress toward many SDGs, especially as the most affected communities in the tropics are also some of the poorest. In addition, lower productive potential means that affected countries have diminished capacity to exploit their comparative advantage in tropical agriculture, fisheries, and aquaculture. So their potential for income gains through trade is also diminished. Positive spillovers in the form of improved terms of trade will offset these losses only by a small amount. We have seen how climate change can substantially affect gains from trade. The next question is how trade policy can influence climate change. One channel where trade can affect climate change is through the change in energy demand, particularly from fossil fuels. Trade fuels growth, and growth drives energy demand, which typically expands at least as fast as GDP. Throughout the developing world, fossil fuels provide the vast majority of energy supply, and coal remains the dominant fossil fuel energy source because it is cheap. This is especially true in countries and regions such as China and Southeast Asia, where a focus on trade as the mainspring of growth has dominated development policy. This map shows that almost all new coal-fired power plants currently planned or under construction worldwide are in East, South, and Southeast Asia. Some other countries, notably Brazil and Indonesia, are major global climate change contributors due to carbon releases, which are associated with the conversion of forests and land for commercial agriculture. This pattern of growth has helped with progress towards some SDGs but impairs progress on environmental targets. Can reliance on fossil fuels be reduced without impairing growth, and thus without impairing progress toward key SDGs? One way to begin answering this question is to examine the true costs of fossil fuel dependency. The environmental and health effects of coal-fired power plants, in particular, are well known. Moreover, poor households are disproportionately exposed to these damages, both because of the proximity to the plants and the high costs of mitigating damages, for example, through household air filters and air conditioning. Less obviously, subsidies on fossil fuel consumption have negative effects on fiscal balances while offering the largest benefits to the most energy-intensive activities, which are typically also the least employment-intensive.